Alright, I feel sorry that you guys have had to be rushed through these conic sections. It really is a neat unit, and I feel bad that you haven't really gotten the full exposure and practice that I would have had in a normal year had we not had some of our delays and weather and testing and all that kind of stuff. So this would have been a day, this worksheet I made for a day that was supposed to be kind of one of those musical chairs activities, right, where you guys would do a graph and label as you moved from station to station and would help each other out. And then I have an extra worksheet attached to the back of this that you can find on our math group's webpage that has some extra practice writing equations in graphing form. So, and pulling out the pertinent information. But I wanted to do a couple with you on this video so you could get the full benefit of seeing me work a problem from the beginning to end, because we've done a little bit of it in class, but it's been very rushed, I know, and you guys have been extremely patient, so I appreciate that. So this one is transform the given equation into standard graphing form. And graph the parabolas, making sure to label. Okay, so for parabolas, vertex, focal point, directrix, line of symmetry, and any x and y intercepts. Remember, for a parabola is the only conic that I make you do x and y intercepts for. So here we go. First, I hope you recognize this as being a parabola because you see a y squared, a linear y, y to the first, and an x to the first. No x squared. This is a parabola. Also, since y is squared, hopefully you know that this is a sideways parabola, right? It's either a open right or an open left parabola. So my job is to take this and get it into graphing form. So remember, for graphing form, you've got the graphing or standard form is the squared stuff on the left side of the equation, then we have 4p, the dilation factor, and then the linear stuff on this side. So to try to match this form, I'm going to take our equation and I'm going to take the squared stuff. Since y is squared, I'm going to take the squared stuff, move it over to the left, and then I'm going to have the linear stuff over on the other side. Now in reality, so I don't deal with negatives and all that, I'm actually just going to leave the 1/3 y squared minus 2y on the right side, and then I'm going to take this -9 and move it over here, so it's x plus 9. Then I'm going to use a reflective property, yeah, of equations and say 1/3 y squared minus 2y is equal to x plus 9. So that's where I'm going to start. So I've got collected, right, so I'm after a group squared, and here's my y squared that I'm going to turn into that, and then here's my linear and my constant stuff. So, completing the square now, I'm going to factor out 1/3, and remember the D word for factor is divide. So y squared minus, oh dagger, 2 divided by 1/3, right, is 2 times 3, so 6y, leave a space, is equal to the linear stuff. Now, I'm going to complete the square, right? Divide -6 by 2, get -3, square it, get +9. And then over here, do not add just 9, right? Because we put this 9 here, but it was inside a parentheses that is being multiplied by 1/3. So I need to take 1/3 times 9 and add that over here, which of course 1/3 times 9 is 3. So now, still in completing the square phase, okay, so I'm getting there, right? Can you see up here? This is where I'm trying to go. I do have a group squared, and I do have a linear group, x plus 12. I'm missing the multiplier in front. So I have a multiplier on the left side and I don't want it. I need a multiplier on the right side and I don't have it. So I'm going to take this equation and I'm going to multiply by 3 so that I have no multiplier on the left side, and I'm not going to distribute the 3. I'm just going to multiply the whole right side by that 3. And now I've got my multiplier. And do you remember what we called the multiplier now? We didn't call it. Now that we're in conics, we know that this is equal to 4p. So I say to myself over here, self, the vertex is not equal to 3, negative 12, right? The x-coordinate of the vertex is with the x, negative 12. And the y-coordinate of the vertex is with the y, and that's a 3. And then I know that 4p is equal to 3, therefore p must be equal to 3 over 4. Now I can graph. So I'm going to erase this, all of this information, and I'll repeat this so that I can draw a graph. Before I do that, though, I want to highlight, pun intended. I have now got, here's my graphing form of a parabola. Since it's a sideways parabola, it's the y stuff that is squared and the x stuff that is linear. 4p is positive, so now I knew when the y that I had, since I had y squared, I knew it was a right or a left, but since the 4p is positive, I know I have an open right. So I know that I'm going to be drawing a sideways parabola, opens to the right. So I'm going to copy the graphing form up here. We did our algebra, and this is y minus 3 squared is equal to 3x plus 12. So again, my vertex is negative 12, 3, and 4p is equal to 3, therefore p is equal to 3/4. So to graph, I'm going to say my vertex is at negative 12 and 3. Label. I know this opens to the right, so I know the directrix is going to be on the left side, and the focal point is going to be on the right. How I find, oh, that's terrible. Right? The whole idea of the parabola is that p is the same value, the same distance from the directrix to the vertex as the vertex to the focal point. So, and what is that? That's still not much better, is it? So, what is that distance? Well, that distance is 3/4. So, I'm going to add 3/4 and get the coordinate of the focal point. So if I have negative 12 and I add 3/4 to it, I'm going to be at negative 11 and 1/4, comma 3. And if I go a distance of 3/4 to the left, this directrix is going to be at x equals negative 12 and 3/4. So I know my parabola is going to do this. Kind of, sort of, right? And I can see that I'm going to have one x-intercept and two y-intercepts. So I have labeled the vertex, I've labeled the focal point, I've labeled the directrix. Whoop! Haven't done my line of symmetry. My line of symmetry is perpendicular to the directrix and goes through the vertex and the focal point. And since the directrix is an x equals line, the line of symmetry is going to be a y equals, or horizontal line, and it's at the level of the vertex. To find an x-intercept anytime, any place, anywhere, what do? Yep, plug in 0 for y. So that is 0 minus 3 squared is equal to 3 times x plus 12. So that is 9. Please don't distribute 3. Divide it off. So when y was 0, x was negative 9. To find the y-intercepts anytime, any place, anywhere, what do? Yep, you got it. 0, 4, x. So y minus 3 squared is equal to 3 times 0 plus 12. So y minus 3 squared is equal to 36. And how do I undo a square? Please don't say square root. Say plus minus square root. So y is equal to 3 plus or minus 6, which is equal to negative 3 or 9. So I have a y-intercept when x is equal to 0, y is equal to 9, and when, x is equal to 0, y is equal to negative 3. So I have my line of symmetry labeled, and I have x and y intercepts labeled. I have my axes labeled, so I get full credit. All good. So there is a sideways parabola. Let's move on. And the next one, I purposely gave you an equation like this because this is our first semester, right? Oh, this is our quadratic function. Look, it has what we used to call a dilation factor in front of the x squared is 1/5, a b value of positive 2, and a little c value of negative 11 over 5, which is the y-intercept, right? So, but we're going to put this into our graphing form. The x is squared, so we want x stuff squared is equal to 4p, y stuff not squared. So again, I'm going to kind of leave this on the right side, move the 11/2 over, and then use the reflective property. Of equations to do that. Factor, the good F word. Then I'm going to complete the square. And again, remember, what have I added? I did put a 25 on the left side, but I put a 25 inside a parenthesis that is being multiplied by 1/5. Now watch this cleverness. 1/5 times 25 is 5. I know that, you know that. But I'm going to add 25 over 5. I'm going to add 5 this way. Why? Come on now. Because I have a common denominator. This is now 1/5 x plus 5 squared. Look where we want to go. Up here is where I want to go. I have the x stuff squared, but I have a multiplier in front I don't want, and I need a multiplier in front of this. So now I see all the information I want. X coordinate of the vertex, y coordinate of the vertex, 4p. Center, -5, -7 1/5. Whoops. Vertex. 4p is equal to the dilation factor in front of the linear group. So 4p is equal to 5. Therefore, p is equal to 1 1/4. So now let's graph this one. Kind of sad axes, right? So my vertex is at -5, -7-ish. Since my 4p value was 5, which was positive, I know that the parabola with x stuff was either up or down. And again, I could see from here that my dilation factor was going to be positive, so I know I open up. So I am going to draw my directrix. I hope you can see that. My directrix is at the bottom. My directrix is at y equals 5/4 units down from -7 1/2. So watch me be lazy. If I'm running out of time on a test, yes, I write it like that. That's my directrix. My focal point is at -5, comma, -36/5 plus 5/4. Bless you, bless you, bless you. It's my little boy. Since I open up, and again, I know my parabola is going to go up away from the directrix and capture the focal point. Since this is a quadratic function, I'm going to have 2 x-intercepts and 1 y-intercept. How do I find an x-intercept? I go back to the equation and I put 0 in for y. So to find the x-intercept, I have x plus 5 squared is equal to 5 times 0 plus 36/5, which, shocker, is just going to be 36. So I have x plus 5 is going to be equal to plus or minus the square root of 36, or x is equal to plus or minus 6 minus 5, which means my x-intercepts are at -11 and 1. My y-intercept comes when I make x 0. Write that over here. My y-intercept is 0 plus 5 squared is equal to 5 times y plus 36/5, and then I say, duh, I don't need to do that. Look back at my very original equation. Don't I have my y-intercept right here? Right? and then I will sketch. Okay, what points have I lost if I turn this in right now, if I'm being graded on a test right now? You always know there might be a point for labeling your axes. But what else have I missed? I've got the directrix, I've got the vertex, I've got the focal points, I've got both X intercepts, I have a Y intercept. You got it. I missed the butterfly line. And the butterfly line is vertical, so it's X equals the X coordinate of the vertex. Alright, parabolas. There, we did a sideways one and a up-down one. Let's move on. This time, we are going to be graphing hyperbolas. So, this time, instead of going to the graphing form where I have a 4p and I have a squared and a not squared, for hyperbolas, I know I've got to go to a group squared and another group squared, and I'm equal to 1. And one of these groups is going to be, well, this is going to be X stuff, and this is going to be Y stuff. And one of the groups is going to be positive, and one of the groups is going to be negative. And that's because they told me I have a hyperbola. Without telling me I have a hyperbola, right? You know, don't you? Right? That's from our list. If A does not equal C, or simply if A and C have different signs, neither one of them equal to 0, but they have different signs, I know I have a hyperbola. So I'm looking to go to X stuff squared, Y stuff squared, and either the X is going to be positive and the Y stuff is going to be negative, or vice versa, the other way around, where the Y stuff is positive but the X stuff is negative. So let's do the algebra to find that out. So group your X's, group your Y's. Move your constant over. Factor. Please be careful when you're factoring out your negative. Complete your square. Divide -2 by 2, you get -1, square that, you get 1. Divide -8 by 2, you get 4, square that, you get 16. Now, you are going to add, don't forget, you are going to not just add 1, you're going to add 1 times 9. And you are not just going to add 6, you are going to add 6 times -9. Add 9 times 1. Add -9 times 6. Whoops, my bad. This is 16, is it not? Right, divide by 2, get 4, square, get 16. So now I have 9 times factor minus 9 times factor What must I have on the right side for graphing form? See what you want, make it happen. Follow the rule of algebra. Do whatever you want to one side as long as you do the same thing to the other. Now, notice that the dilation factor here, or the multiply here, is positive. Divided by this positive denominator is still going to leave my X group positive. But it's going to be X minus 1 squared on top of 9. I have a -9 and a positive 81, so that is going to leave a negative y group on top also of 9, and this is equal to 1, 81 divided by 1, 81 divided by 81. Now remember, for a hyperbola, I've got vertices on the wings. I have a center. I have focal point, and I have equations of asymptotes. So let's pull out our information. So we have a center of 1, 4. Our x is under the x stuff. And that's not 9, right? That's 3. Our y, in this case, is also 3. Now, who got cut? Remember that from the lesson? I said one of these vertices, it's kind of, you know, like think of it like it used to be an ellipse, and you're going to cut one of the vertices. Who got cut? Right? The cut goes with the negative. Here's the negative. It's in front of the y stuff. So the y, here's my pathetic scissors. The y acts, you cut through the coordinates, the vertical coordinates. Therefore, our x is A and our y is B. Our x is the transverse axis and connects the real vertices. And our y goes with B, and B, or 2B, goes with the conjugate axes, and these are with the cut or the fake vertices. So I have to find C. Remember, who's the big dog on the block here between A, B, and C in a hyperbola? Remember we did this in class? It's not A anymore. C is the Pythagorean big boy. Remember, in an ellipse, A squared is on the outside. So here, C is going to be equal to A squared plus B squared, which was 9 plus 9, which was 18. And since I want, that's C squared, and since I want C, C is equal to plus and minus the square root of 18. So we're going to use all of this information to graph. And don't forget, I also gave you the notes for the slant asymptote, that the slope of the slant asymptote can also be found from our x and our y. The slope of the SA, not the sinusoidal axis from last unit, the slope of the slant asymptotes. Slope is always y on top of x. So for us it's radiate y, radiate x, and that's 3 over 3. So for us, our slope is 1. So we're going to take all of this information. I'm going to erase this screen in a sec. Take all this information and we're going to graph our hyperbola. So I'm going to make all this go away. And then I'm going to write some of that information on the top. So we found, remember our graphing form, from our graphing form we found that our center was 1, 4. Our x and our y were both 3. We had cut through the y's because the y group were negative in graphing form. Therefore, our y was B and our x was A. We also found that C was equal to the square root of 18, and I put plus or minus. I really should put plus and minus in front of all of these things. So let's graph. So we're going to put the center in first. 1, 4. Now remember, these are my real vertices because I cut through the vertical ones, the y ones. So I'm actually going to radiate 3 units out to the right. Where does that land? That's right, 4, 4. Radiate 3 units to the left. Don't draw your wings yet. Okay, these are the vertices of your wings. Oh, those are so off. There, fix it that way. These are going to be where my wings of my hyperbola are, but I'm not going to draw them yet. I'm going to go ahead and radiate 3 units up. I'm not going to label though. 3 units up, 3 units down, and I'm going to lightly sketch a rectangle. And I want you to convince yourself that this rectangle, and yes, I know that in this case it's a square, that the transverse axis, which connects the real vertices, is the same length as, I think I'll make this highlighted, the length of the transverse axis through that vertex that you cut, length of the transverse axis. Remember, the length of the conjugate axis connects the vertices that you ended up cutting, but that same length I've now copy and pasted over here. And I've done that because I said I wanted you to sketch the slant asymptote through the center and through the diagonals of your rectangle. Through the center. There's your slant asymptotes. Once you have your slant asymptotes, now you can sketch your wings along the slant asymptotes. Wings along your slant asymptotes. You do not have to find X and Y intercepts of these. I should have said way back when we did the graphing form that since we ended up with our X group positive, that's how I knew, since the X group in graphing form was positive, that's how I knew I was going to have a right-left parabola. But I'm not done. I have labeled the vertices. I have labeled the center. So check, check. You do not have to label the vertices that ended up being cut. And I would prefer, though I'm not going to take points off, if you erase the rectangle that you made to shape your asymptotes. But I do need you to still add your foci and the equations of the asymptotes. So let me tell you one of the #1 mistakes with foci. People will remember that they are in the right soup spoon here. But when they label the foci, they know they need to add this root 18, but they tend to add it sometimes to the vertex coordinate. No, 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 no. C, remember, is a distance from the center. So the coordinates of the focal point is since I'm horizontal, my transverse axis is horizontal, I need to take the x coordinate of the center and add root 18 to it, comma 4. And then this focal point is the x coordinate of the center minus root 18, comma 4. And then, hello Algebra 1, the equation of any line in our best friend point slope form is simply y minus the y coordinate of a point that it passes through is equal to the slope parentheses x minus the x coordinate. Well, hello, what point do they both, those slant asymptotes, go through? What point is this? Why, it's the center. So both of these equations are going to have the center. This blue line goes through the center, 1, 4, and so does this slant asymptote go through 1, 4. But what is the slope of this positive blue line, slant asymptote? Rise over run. But look at that, that traces right over where we had our rectangle, right? Rise, conjugate axis, ry, run, half of the transverse axis, rx. That's why I said before that the slope of the slant asymptote is ry over rx. So ry is 3 and rx is 3, so for us this happens to be 1. Well, this blue line, rise 3, but run 4 in the left direction, so this is negative 3 over 3, or negative 1. So of course, if you don't have to write the 1 or the negative 1, if you really want to get it, you just love slope y-intercept, go ahead, it's all integers, but you don't need to. So now I am done. Oops, just in case. X, y. All right, on to our last one then. So another equation that I'm given in general form, and I'm expecting that you would recognize that it was a hyperbola, because you would look at A, positive 25, you would look at C, negative 16, you would say A and C have different signs, therefore I'm a hyperbola. So I'm going to go through the algebra pretty quick, right? I'm going to go to the graphing form of x group, y group, and equal to 1. So I'm going to have 25 x squared minus 100x minus 16y squared plus 96y is equal to negative 356. Factor 25 out. Be careful. Divide negative 4 by 2, square it. Divide negative 6 by 2, square it. Don't forget to add 25 plus 4. I'm sorry, times 4. So that's adding 100. And don't forget to add negative 16 times positive 9. So that's adding, if you will, a negative 144. So I end up with 25 factor I need a 1 on the right side. Golden rule of algebra. But look what happens now. Notice that when I was in general form, the y stuff was negative. So you might be thinking, oh, I'm going to cut the y's. You can't make your cut decision until you're in graphing form, because look what happens to the x group here. I know that looks like a y. I gotta fix that, huh? That first group is an x stuff. Right? Look what happens. The 25 is positive, the 400 is negative. What happens when you divide a positive by a negative? This x group is negative. 25 goes into 416 times. Look what happens here. A negative divided by a negative. My y group is positive now. So since my x group is negative, I'm going to cut through the x's, and my ellipse is going to flip out this way. This is the hyperbola that I'm going to have. So I'm going to pull out my information. Still, I get my center. I need to label my center. I'm going to have to radiate in the x direction. And I'm going to radiate in the y direction, but since I cut my x's, that's the b value, or the conjugate axis, and our y is going to be a. Now I know in both of my examples, unfortunately, the a value, the magnitude, has been higher than the b value, but remember, for a hyperbola that doesn't have to be the case. For a hyperbola, all that matters, you make the decision on who is a as to who did not get cut. Remember, the slope of my slant asymptote is the conjugate, or I'm sorry, the ry over rx. That never changes, no matter the size. Slope is always y on top of x, so this is 5/4. So now I'm going to take this information and I'm going to graph it, and I'll see if I can squeeze the graph over here. So there's my axes, and I'm going to put my center at 2, 3. I am going to radiate in the x direction 4 units. 4 units left and 4 units right. I'm not going to bother to label those because remember, that's my cut. Those are cut. They don't have to be labeled. But I am going to radiate 5 units up. And I'm going to land at 2, 8. And down 2, -2. Right, because I subtracted 5 and added 5. And then I'm going to draw that rectangle. Right? Remember, the conjugate axis connects the vertices that got cut, but the length of the conjugate axis I'm going to draw here and here. The transverse axis connects the vertices that are still there, but I'm going to draw the length of the transverse axis on the outside here. And I'm going to draw my slant asymptotes through the center and through the diagonals of this rectangle. And then again, not required to get rid of this. But if you're doing this for somebody besides me, you should. And now I'm going to use those slant asymptotes and my vertices that I didn't cut to draw my wings. Free! The wings are free! So I've labeled my axes, I've labeled the vertices on my wings, I've labeled my center. But don't forget, you need to label your focal points. And your focal points don't come from A and they come from B, they come from C. But remember, in a hyperbola, C squared is the largest of the three values in our Pythagorean relationship. So we're going to add the other two, A squared plus B squared. And 25 plus 16 is usually 41. And I write the plus or minus there to remind myself to do both. So since this is, the transverse axis is vertical, the x-coordinate of the center is going to stay the same, but I'm going to have the y-coordinate 3 and subtract root 41. And here I'm going to have the x-coordinate of the center, the y-coordinate of the center, plus root 41. Still missing the equations of the asymptotes, but the equations of the asymptotes are our old Algebra 1 point slope form of a line. What point do both slant asymptotes have an infinite amount of points on them, but they both share one point, and it is the center of a hyperbola. So why not use that? So the x-coordinate of the center, the y-coordinate of the center. Whoops. The x-coordinate of the center, the y-coordinate of the center. And the slope of the slant asymptotes, rise, which is ry, run, which is rx. So ry is 5 over 4. And the slant asymptote on the other side is exactly the same magnitude. The slope is the same value, right? Or number, magnitude, but you rose and went left, so negative 5 over 4. And there you have it. There you have your hyperbola graphed and labeled. I hope this helped you doing 2 parabolas and 2 hyperbolas. On math groups, there's this sheet with these problems as well as some other problems that you can practice writing the equations of and doing some graphing. I won't collect it, that won't be checked, and I'll have the solutions on our Edline page just so that you have some extra practice. Again, thank you for your patience with rushing through this unit, and I hope this video helped make up for it a little bit. I'll see you tomorrow. Bye.